Okay, welcome back. So in this video series I'm putting together, I'm trying to do some programming in ARM assembly, and the goal here is to create a simple number guessing game. That would be very easy to do in a higher level language, but in ARM assembly, or probably in any assembly language, we have to do quite a bit more legwork. So let's go ahead and continue on. Let me just put this back where it was. Okay, and make that a bit smaller. All right, so in part one, I established the basic structure that's necessary just to be able to assemble and link any ARM assembly program, and then we added a prompt so that when we run the program, it will put a message out to the screen, but it doesn't do anything more than that at this point. Okay, so one of the next things that I want to do is to start receiving input from the user. So let's go back to the system call reference and take a look at that. So to read input, we need the syscall name read, and it's right there. And again, it's really small, so what I've done is I've taken these lines and kind of typed them in a larger font here and translated some of the language into what makes more sense for what we're trying to do here. Okay, so let's put a comment here and we'll say prompt, because that's going to be like the section that prompts. And we're going to come back to this at some point, probably, because I don't want to have to count up the characters for every prompt, and we can do a little bit better. So let's handle input. And what we need to do to get input from the user is we need to move into register 0 standard in, and that standard in isn't defined, so we'll have to go back up to those equivalency areas that define portion and define that. And then in register 1, we need to, it's a pointer type, or it's a memory address. So we need to load into register 1 the memory address of something that I'm going to call input. And then we need to move into register 2 the size of that input, or the length of that input. And that's not defined yet, so let's define that as input size. And then finally, we need to move into register 7 an immediate value of 3 in order to read, but let's avoid having hard-coded numbers like that, and let's just say read. And then finally, we need to make a supervisor call, so let's do that. All right, now let's first of all get these defined. So we need standard in, which is going to be 0, and we need input size, which we'll have to think about that, so let's come back to that in a second. And then for the read, we want 3. Okay, so let's create a prompt, or not a prompt, but let's create a variable to store our input. And let's do, the type will be .ds, and the size of ds we'll do single byte, because we only need a couple of characters, because they're going to type a number between, for example, 1 and 100. So that's going to be 3 characters at most, plus a carriage return, for example. So 4 characters at most that we need to save. So the size will be input size, which we haven't declared yet, so let's do that. Input size, and let's make the input size 10, so they could potentially type up to 10 characters. But we're only going to, for a guessing game of 1 to 100, we're only going to care about those first. 1 to 3 characters. All right, let me bring this up for a moment so we can see. Let me search this. So where am I getting this DS from? If we go to the contents of this sourceware.org binutils docs document and we search for like DS, it says this directive emits number, so that number, copies of fill, each of size bytes, and then the size is here. So both number and fill are absolute expressions. If the comma and fill are omitted, fill is assumed to be 0. The size suffix, if present, must be one of .b, .d, .l. And I'm using the .b size suffix for single byte values. If you omit that value, it defaults. So if it's omitted, it defaults to .w, which would be 2 byte values. So this isn't, I mean, we could use any of these probably, but we'll just do single byte values. And the input size, the number, for our number we're doing 10. So 10 bytes essentially. And then the fill, which we currently we don't have fill in ours, but it's optional, and if you don't include it, it defaults to 0. But just so that we aren't unsure of what that is, we'll put I guess we could just say fill like that. I was going to put 0, but I guess we can just declare it that way. Fill value, and it's 0. So now it's going to be 0. Okay. So let's take a look at what we have. And I think that looks okay. Let's go ahead and write that. Let's quit out. And let's go ahead and make this. And I forgot to mention, I've created an extra file here called vid1_main. And what I did was just at the end of the last video, I just copied main.s to vid1_main.s. That way I've got a backup copy of what the file was at the exact moment that I stopped recording. So if I want to put each piece, like if I upload this to YouTube and I want to put each file in the description or something, I have a copy of the file as it was at the end of the video. And I'll do that again at the end of this video. Hopefully I remember. All right, so we have made our program, so let's run it. And let's just type something in. Okay, so it accepted our input. Okay, now let's take a look at what this looks like in the debugger. So let's run gdb main, and let's list out our code, and let's put a breakpoint at 30, so just before we exit. That way we can take a look at what register 1 looks like just before we exit. And it should contain the ASCII value of what we typed in. So if we type 3, it won't contain the number 3, but it will contain, for example, the ASCII value of 3, which is 51. And if we typed, 9, then it would contain 57. All right, so set a breakpoint at line 39, and let's run our program. And let's use 3, which has an ASCII value of 51. So we think register 1 should have an ASCII value of 51, and obviously that's not an ASCII value 51. Let's copy that though. Let's see what that actually is. It's something totally different. Okay. But the thing is, we also have, when we type in our number and hit enter, we also have a character turn off on there. So what we need to do is we need to look at each individual character. So let's continue through to the end of the program and quit, and let's bring up our our file again. So after we do the service call, let's look at the values. So let's load a byte, a single byte, and let's load that into, say, register 3, and we want to load from register 1, and we want to look at 1 byte, just whatever the first byte is at the memory address, or we want to look at the first byte of whatever was typed into as input, and we just want to look at 1 byte for now. All right, so let's write that, let's quit, remake, and let's look at this in the debugger, and let's put a breakpoint at 42, and let's run this, and then again let's use the number 3. Okay, so we typed in 3, and we have in register 3 is what we're looking at now. We have 33, and in ASCII 33 is an exclamation mark. I was expecting it to be 51. Oh, wait a minute though, we have to convert it. So we have this, which we have to convert, 51, and the ASCII value of 3 is 51. Okay. So we got the correct ASCII value of the number we typed, the 1-digit number. At this point, it won't work with 2 digits. So let's continue through to the end of the program. Let's quit. Let's subtract off so that we can have the actual value. Let's subtract off the difference between the number we typed and the actual numeric value we're trying to represent. So the difference between 51 and 3 is 48. So, and that'll be true for every number. So if we take and we say that we let me actually quickly just get all these spaced out, because we're going to need a bit more room there. So that I just like to have things lined up. Okay, so if I put all those like that, then they're going to be lined up. Now so I'm going to say make register 3 equal to the value of register 3 minus the immediate value of 48. I think I can do that. Let me see if that's valid. I might have to look up the syntax for subtract. Make. All right, that seems valid. All right, let's look at this in the debugger again. So gdb main, and let's set a breakpoint at 43 and run this. So now we're going to type in the number 3. And yeah, let's see here. Register 3. Okay, so register 3 now contains the value 3, because we got that byte, and then we subtracted off the difference. So register 3 now contains the value 3. So let's continue it through to the end of the program. Let's run it again. Now we'll type in the number 9. So we expect register 3 to contain the number 9. And register 3 contains the number 9. And let's continue through to the end. Let's run it again. Let's try the number 5. And now register 3 contains the number 5. Okay. Continue through to the end, quit out of this, and let's reopen our program. So now the issue is going to be we we're going to be allowing characters, or we're going to be allowing numbers between 1 and 100, 1000, or whatever. So we need to actually create a loop to go through each character that was typed in, because if we look at this in the debugger and we do like the number 15, we're only going to be getting the value of 1. We won't get 15. So let's look at that. So list this out. We need break 43. Let's run this now. So let's type in a 2-digit number now. Let's do 35 as an example. So register 3 is only going to contain the number 3. Yeah, register 3 only contains the number 3, which you can see here. And if we do this, like if we continue through the end, run it again, and we do 55, register 3 is only going to contain the first number from left to right. It's only going to contain that first digit. So continue through to the end, quit. So yeah, what we need to do now is we need to iterate through each number that was typed and then add it all up. Okay, so let's I don't want any of these individual videos to be too long, so let's go ahead and leave things where they're at. And when we come back, we'll look at creating a loop to go through each character that was typed, and then add everything up to, like, so if they type 15, then register 3 will actually contain 15 when they're done, as opposed to just the number 1. All right, so that's going to wrap it up for part 2. Thanks for watching, and I'll see you in the next video.